Friends, we have discussed in the last session, that is session 4, about the production of phosphoric acid by electric furnace process and direct oxidation of elemental phosphorus. These two processes we have discussed in the last session, that is session 4. The electric arc furnace process, the phosphorus formed in the electric furnace from reacting the phosphate rock, ground phosphate rock with sulfuric acid. And the phosphorus vapors thus formed are actually taken and fed to a combustion chamber where the phosphorus pentoxide is formed. Phosphorus burns in presence of ambient air and phosphorus pentoxide is formed along with some carbon monoxide and water in the form of mist. All these are actually taken to a water scrubber so that the phosphorus pentoxide actually dissolves in water and the mist is separated from carbon monoxide in an electrostatic demister. Demister is the equipment where mist is separated from carbon monoxide here. And the acid which is obtained in the water scrubber is at a concentration of 85% and it is then subjected to purification process wherein strong sulfuric acid is added to convert any calcium salt into calcium sulfate. Hydrogen sulfide gas is bubbled through the acid mass to convert any arsenic which is present in the acid to arsenic sulfide. And powdered silica is added to remove hydrogen fluoride, which is actually comes from rock phosphate. When phosphate rock contains calcium fluoride also, so this fluoride also comes into the acid. So this fluoride content has to be removed. It can be removed by treatment with powdered silica. The powdered silica is converts the hydrogen fluoride into silicon hydrogen fluoride. All these impurities, calcium sulfate, silicon hydrogen fluoride and arsenic sulfide, they all precipitate and form sludge at the bottom of the reactor from where it can be taken out and discarded. The treated acid is taken out as overhead product and it can be used in the manufacture of fertilizer or food chemicals or in soaps and detergents. The another method of phosphoric acid manufacture is from elemental phosphorus. Actually, that process is actually used at the remote areas where the demand for phosphoric acid is high. There the elemental phosphorus is oxidized to phosphorus pentoxide and phosphorus pentoxide is absorbed in water which gives phosphoric acid, and then this phosphoric acid can be purified by treatment with sulfuric acid, hydrogen sulfide and powdered silica as it is treated in the previous process, right? So these are the things which we have studied, and we have seen the flow charts for each process. We have seen what are the equipment used there. Today in the session 5, we discussed about the manufacture of hydrochloric acid, HCl. It can be produced by two methods. One is starting raw material is sodium chloride, common salt. It requires sulfuric acid and water as other raw materials. In the other method of production, here hydrogen and chlorine are actually combined and made to react each other in a reactor in the synthesis process, and hydrogen chloride gas obtained is actually absorbed in water in carbon lined or plastic rubber lined reactors, because hydrochloric acid is a highly corrosive liquid. Next to sulfuric acid, hydrochloric acid is of major importance in chemical industry. The, raw, the reactions are sodium chloride NaCl plus H2SO4 gives H2SO4 plus HCl. NaCl plus NH sodium bisulfate gives sodium sulfate and HCl. So when sodium chloride is reacted with sulfuric acid and sodium bisulfite are formed, and HCl is obtained here as a byproduct. Right. Next, we see the flow sheet. Here, the raw materials like sodium, common salt, sulfuric acid are fed to a furnace, and it is actually heated at a temperature of 400 degrees centigrade temperature, where the reaction between sodium chloride and sulfuric acid takes place. It forms sodium bisulfite, sodium sulfate, and hydrochloric acid, and then it is sent to gas cooler. The B is the gas cooler and C is the coke scrubber. Here the hydrochloric acid is scrubbed with coke to separate the other entrained particles, and then the acid, hydrochloric acid, is then fed to cooling coils which are provided in the absorber there, and that is then after cooling the product is actually taken to a absorption tower where water is used. The unabsorbed gases of gaseous hydrochloric or hydrogen chloride, I mean to say, that is actually absorbed in the tower D, that is an adsorption tower, which is lined with acid resistant or corrosion resistant material. After absorption, the product is taken and it is recycled back to the first absorber, where further the concentration of hydrochloric acid increases and the finished acid is taken out from the bottom of the first absorber. Right? So we see the flow process in detail. The NaCl and sulfuric acid are fed to the reactor in the desired proportion and is heated to about 400 degrees Celsius. To promote the reaction rate, it is desirable to have the temperature sufficiently high to keep at least one of the components in liquid condition, either sodium chloride or sulfuric acid. In the first stage reactor, it is not so difficult to decompose, but in the second stage, it requires higher temperature to liquefy sodium bisulfate. It is not desirable to increase the temperature beyond this temperature, that is 400 degrees centigrade temperature, both to reduce the attack of corrosive reacting mass on the furnace and to favor the equilibrium to separate the reaction products. The sodium sulfate as a separate solid phase. Since salt does not melt, mixing is required to complete the reaction. The HCl is thus produced, is purified and stored. Purification is done by distillation. Distilled and purified and then stored. This is the process which takes place in the production of hydrochloric acid from common salt. The next method is by synthetic hydrochloric acid production. Here the raw material required are hydrogen and chlorine gas and water for absorption. Reactions involved, we can see the reactions here. Hydrogen gas and chlorine gas are actually combined to give hydrogen chloride gas. Hydrogen chloride gas. This hydrogen chloride gas is absorbed in water, gives hydrochloric acid, aqueous acid. Here hydrogen and chlorine are fed to the reactor in 1:1 proportion. This is the flow diagram. Hydrogen and chlorine are fed to a burner where it actually reacts each other and forms hydrogen chloride gas. This hydrogen chloride gas is then fed to a stainless steel water cooled shell in which water is sprayed from the top, and it is inside, it is lined with structural carbon to avoid corrosion of the adsorbent. Here gas is absorbed in water which is sprayed from the top, and HCl gas flows counter current to that, so that the HCl gas dissolves in water and forms hydrochloric acid, aqueous hydrochloric acid at the bottom. Right? Hydrogen and chlorine gas enters the bottom in such a proportion that slight excess of hydrogen is maintained. The reaction is started by igniting the burner with an external bare hydrogen torch. The hydrochloric acid gas is conveyed to the absorber. The absorber consists of polyblock section of structural carbon cased in shell of this steel construction. Pure hydrochloric acid gas, that is 98%. The absorption is rapid and external cooling may be used. The strength of the acid produced is around 32 to 35%. This is the process taking place in the synthesis gas route for the production of hydrochloric acid. Let us see the properties and application. The boiling point of hydrochloric acid is 83 degrees Celsius. It is very soluble in water, hydrogen. Hydrogen chloride gas is relatively inactive. Its aqueous solution is extremely corrosive to all metals. But in the gaseous stage, it is not corrosive. When it forms an aqueous solution, then it becomes corrosive to all metals. Applications: it is an important mineral acid next to sulfuric acid because of its volatility. It is used in the manufacture of ammonium chloride, metallic chlorides, cleaning agents for metals, sheets, coating with zinc, tin, or lead. So these are the properties of and applications of hydrochloric acid. Thank you.